Alright, I'm going to start off by factoring out 9 to the power of x from my left-hand side, because all my terms are 9 to the power of x. And from here, 1 plus 1 plus 1 is going to be 3, so I get 9 to the power of x times 3 is equal to 999. So now I can divide both sides by 3 so we can isolate x. So now I get 9 to the power of x is equal to 999 divided by 3, which is 333. So now we have a much simpler equation from what we started with. So now to solve this, what I'm going to do is rewrite 9 as 3 squared. So now I have 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning 3 to the power of 2 to the power of x is equal to 3 to the power of 2 times x, which is just 3 to the power of 2x. So now this is equal to 333. Now what I'm going to bring into this equation are logarithms. And it's always useful to use logarithms when solving exponential equations because they're very helpful. And one of the reasons they're helpful is because they come with an important property that states that log a to the power of b is equal to b times log a. Meaning log 3 to the power of 2x, I can just move this 2x to the front. So I get 2x times log 3 is equal to log 333. And now I'm going to divide both sides by log 3. So I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in this form, this is the same thing as log 3 plus log 111. Now this is the same thing as log 3 over log 3 plus log 111 over log 3 which is equal to 1 plus log 111 over log 3. Now log 111 is the same thing as log of 3 times 37. So now this is equal to log 3 plus log 37 over log 3, which now it turns into log 3 over log 3 plus log 37 over log 3. And this is equal to 2 plus log 37 over log 3. So now if I divide both sides by 2, these two cancel out, these two cancel out. So I get x is equal to 1 plus log base 3 of 37 over 2. And this is the same thing as 1 plus log 37 over 2 times log 3. So this is my solution to this equation. Alright, so in this video, I'm going to solve the problem 2 to the power of 30 minus 1. So to solve this, I'm going to rewrite this as 2 to the power of 15 times 2 minus 1. Now if I have something in the form a to the power of m times n, This is equal to a to the power of m to the power of n. So 2 to the power of 15 times 2 is the same thing as 2 to the power of 15 to the power of 2. And negative 1 is the same thing as negative 1 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power of 15, and b is 1. So now I have 2 to the power of 15 plus 1 times 2 to the power of 15 minus 1. Now, 2 to the power of 15, well, what's the value of that? Well, 2 to the power of 10, this is 1024. So 2 to the power of 11 is double of 2 to the power of 10, which is double of 1024, which is 2048. So now 2 to the power of 12 is double of 2048, which is 4096. 2 to the power of 13 is double of 4096, which is 8192. 2 to the power of 14 is double of that, which is 16,384. And finally, 2 to the power of 15, this is double of this, which is 32,768. So I have 32,768 plus 1 times 32,768 minus 1. And now this is equal to 32,769 times 32,767. Now, a simple way to solve this, instead of having to actually multiply them the regular way, is to write this as 32,000 plus 769 times 32,000 plus 767. Now I'm going to distribute. So I get 32,000 times 32,000, which is equal to 1024,000,000. This is 1,024,000,000. And now I have this plus 32,000 times 767, plus 769. And finally, I have at the end 767 times 769, which is equal to 589,823. So let me add all of this up. You can actually do this on paper if you want, but just to make this easier, I'm gonna use a calculator to add all this up. So if I add all of this up, I get 1,073,741,823. So this is my solution.